In this presentation, we'll review solving complex radical equations. This is a supplement to our in-class work and is not meant to be an all-encompassing overview of solving radical equations. You will recall from our classwork that we used the Powers property of equality to solve radical equations. The Powers property of equality states if A equals B, then we can raise both sides of the equality to the same power and the equality is maintained. Let's look at our first example. We have radical x plus 3 plus radical x minus 3 equals 3. The process is to isolate one of the radicals on one side of the equal sign. So we're going to isolate radical x plus 3 onto the left-hand side. We then raise both sides to the same power to eliminate the radical. In this case, because it's a square root, we will square both sides, and we obtain this result. We now simplify, and we want to isolate the radical once again. In this case, we have radical x minus 3 equals 1/2. We again square both sides, and then we solve for x. When we square equalities, we run the risk of introducing what's called extraneous solutions. Extraneous solutions are solutions that do not satisfy the original equation. Therefore, we must verify any result we obtain. Substituting our result, 13/4, into both radicals, we obtain the following. We simplify. You see that 13/4 does satisfy the equation, and thus it is a solution. Let's move on to our second example. Here we have two quadratics underneath radical signs. The procedure is the same. Isolate one of the radicals to the left-hand side of the equal sign. Square both sides. This may seem a bit complex, but if you work through it, you'll realize that this is the result. Again, we simplify, and we end up with radical x squared plus 3x minus 1 equals -3. We now have a simpler radical equation, but we still have to square both sides, and we obtain the following. You should notice that this is an equation of quadratic form. To solve quadratics, they should be equal to 0. So we subtract 9 from both sides, factor, and our solutions are -5, 2. These need to be verified. We substitute them both into the radicals, and you can see that 2, when it's substituted and we solve, does equal 1. And when we do the same with -5, it also equals 1. That completes the presentation.